So welcome back to another episode on Tutor Think. In this one, I am going to apply what we call the Keren divider rule to solve this particular question. So previously, we spoke about the Keren divider rule and the voltage divider rule. And so I want to take just one example under the Keren divider rule. For the voltage, it is very simple. So I don't think there's a need to do that. So you can locate Keren divider rule and voltage divider rule in my playlist network analysis. So just locate the channel at Tutor Think 130 on YouTube and locate these videos in the same playlist I just mentioned earlier. So look at this circuit very well. It looks a little complex. The question says that we should find all the branch currents. So the current through branch 1, branch 2, branch 3, current that will go through all the branches. So let's see how we are going to apply the Keren divider rule to do this, okay? So I'll be drawing other circuits, so you just pay attention and you follow carefully. So now before we start, the first thing we need to do is to label the branch current. You can label this branch current the way you want. So I'll label it the way I prefer. So let's see how I am going to label it. So this is our source voltage, which is 12 volts. So what we need to do is that the current that the 12 volts will supply, which is the total current or the source current, I'll call it IT. So this is my total current. Now the source current will pass through this 2 ohm resistor. A portion will drop here and a portion will go to this junction. So the one that will drop here, let's call it I1. Now the one that will pass here, let's call it I2. The one that will go through this junction, let's call it I3. Now note very well that the current I2, the value of this current will supply this node, which is this junction, and it will split into 2, giving you I3. Let's label the one that is going here to be I4. Now, when I4 also travels to this node, it will what? Split into 2. A portion will pass here. Let's call it I5. And then the remaining will pass through this resistor. Let's call it what? I6. So these are the individual current that will go through this circuit, okay? So now let us calculate for the values of each individual current and let's see what we are going to get. Now for you to really understand, I will break this down to the simplest form for you to understand. Now let me explain. Now one of the tricks you need to know is that there are ways that we can solve this, okay? Now when you look at this very carefully, we want to find the current on all branches. Now to do that, we need to first calculate for the value of the total current, which is called the IT. Now before I can find the IT, I don't know the value. The question did not give me the supply current, so I need to calculate for it. And I have the source voltage, but I do not have the total resistance to find the current. So what we need to do is to find the total resistance in this circuit. Okay, how do we do it? We need to resolve this whole circuit. We need to resolve the resistive values, okay, and find the total resistance to be able to find the total current. Now, one other trick I want to show you is that the first thing you need to know is that because we have the voltage source here, I advise that you start the resolving from the right side of the circuit. So we start from here, we resolve in this direction because of this voltage source here. If you can also resolve it from this side and get the same answer, I don't have any problem, but the most important thing is to get the right answer. Let me resolve from this side. Okay, now when you look at these two resistors, 8 here and 9 here are parallel to each other. So we need to resolve these two. Now after we finish resolving these two, it will be in series with the 6 ohm resistor that we have here. Alright, so we can say that this time this over this plus what? This 6 will give us what? The value for resolving this portion of the circuit. So to resolve this one, let us call it RP1, which stands for R parallel 1. So our RP1 will be equal to what? This 8 times 9 divided by 8 plus what? 9. Now when you look here, you could see that when we join this together, it will be in series with the 6 ohm. So I'm supposed to add plus what? 6 here. So that I can solve for 1, 2, what? 3. Leaving 1, 2, 3, 4. Now, to explain for you to understand, let us maintain this one. We will draw another circuit to explain the reason why this and this is in series with this. Okay, so now when we solve this, the result is going to give us what? 4.2353. I want you to write your answer in 4 decimal place since we will be using it again. Okay, I don't want us to miss the values. So write the answer in what? 4 decimal place. So this will give us what? In ohms. So let's redraw the circuit and see what will happen. Now, when you look at this diagram very carefully, you could see that after joining this and this, we have our RP1 to be in series with this. Now the current that is flowing in this direction is now what? I4. That is what we have here. So I4 will flow through the 6 ohm and at the same time what? RP1. So that was why I was saying that as you are solving, once you understand the circuit, when you get here, you don't need to redraw this circuit. You just add this value up to this to get your RP1 value straight. You don't need to draw this. So now our R series 1 will give us what? 6 plus RP1, which is giving us what? 4.2353. Now the value is going to give us 10.2353 ohms. So now we've been able to add this and this together. So we need to redraw the circuit. Now when we redraw the circuit, the resolve value of this side will be in parallel with this one. Okay, and then once we solve both of them together, it will be in series with the what? With the 3 ohm resistor. Now you look at the diagram very carefully, you could see that now RS1, which is the one that we calculated here, is parallel to this 5. Okay, so now we can resolve 5 RS1 and 3 together. This I'm not going to draw the next circuit. Okay, what it means is that this and this will be parallel and it will be in series with this one. So our RP2 is going to give us RP2 equals 5 times our RS1 is 10.2353. So we have 10.2353 out of 5 plus 10.2353. Note, I don't want to draw the series circuit, so we have our plus what? 3. Okay, so now when we punch everything here, we have our RP2 is giving us what? 3.3591. So 3.3591, when you add this 3, you are getting 6.3591 ohms. Now the next thing we do is that we need to redraw the circuit. Okay, so this RP2 will be here. Okay, to be here. So now let's redraw the circuit and see what we have. Alright, so after redrawing the circuit, look at what we are having. So now we resolved 1, 2, 3, and we got this. So we have RP2 in parallel with this one. Together they will be in series with this. So now it is very simple for you to find the total resistance. Okay, so we can find our RT, which equals this times this over this plus this, or plus what? This one. I don't need to redraw the circuit again. Okay, so we have 3 times our what? RP2, which is 6.3591. Divide this result by 3 plus 6.3591 plus these 2. So what we need to do is to add the 2 here. So we can punch everything here on the calculator and it is giving us our RT to be equal to 4.0384 ohms in 4 decimal places. Okay, so now we've been able to find the total resistive value. Now let us find the current RT. Okay, and using the voltage 12 volt, we can calculate for the total current RT. So therefore, our IT equals what? Our V over what? Our RT, which is giving us 12 volts divided by this, which is 4.0384. So from here, our IT is giving us what? 2.9715 amps. So now I want you to be leaving the values in 4 decimal place, okay? Because I'll be using it again. So now, after we've been able to find IT, we can start solving for the individual current through the circuit, okay? Without the total current, you can't do that. So now when we locate here, when we come back here, with IT, we can find I2 and what? I1. But I can't use this diagram. Why? Because I have too many resistors here. So we have to locate what? This diagram. You see, this diagram shows that after we resolved everything that we had here until we got here, we got what? RP2. And the value is what we have at the top here. So now we can find I2 and what? I1 using the current divider rule. So from current divider rule, I can find the value of, let's say, I1. So now 1. My I1 equals what? The opposite resistor times the total what? Current. So I have my IT times my RP2 all about RP2 plus this value. Since I've not labeled this resistor, let me just add it here, 3. So I'll clean my RP2 to put my value 6.591. 6.591. Here we have 6.591 and IT is giving us what? 2.9715. So now when you punch everything here, we are having 2.02 amps. Now this is my final answer for this, so you can run it to 2 decimal place. So this is 2.02 amps. Now let us find the current what? I2 passing through RP2. Remember, it is passing through this branch, okay? This I2 value is passing through this branch. It is coming here. It is coming to this node. So, but the resistor value RP2 will help us to find it. But I don't need to use current divider rule. So I'll just subtract this value from the total current. So our second, which is second solution, will give us what? I2, which is equal to IT minus I1. So our I2 equals what? 2.9715 minus 2.02. So our I2 giving us 0.95 volts amps. So the current I2 passing through this branch, which is the same as this, is giving us 0.95 volt amps. Now, what is the next current? We need to find I3, which is passing through here. So we have to locate a diagram that we've drawn that will help us to do that. So let's go to this diagram. Now, this diagram, we have I3 and I4 passing through this branch. So we can find the value of what? I3. Now, to be able to find the value of I3, we need the source current. Now, the trick is some of you get confused. The IT, which was supplying the total current to this node, which is the same as what we have here, has finished supplying. It went to this node, one was here, one was here. So now this I2 becomes the source current supplying this what? This junction. So when I2 gets to this junction, a portion will drop here to form I3 and a portion will continue to form what? I4. So now we will use I2 to calculate for I3 and I4. That is all I'm saying. So from current divider rule, our third solution becomes our I3, the one we are looking for, the source current, which is I2. Let me go straight forward. What is the value of I2? We have 0.915. So 0.95. Multiply this result by the opposite resistor, not the one I3 is passing through, which is RS1. We got 10.2353. So we have 10.2353. So now you divide this result by the two resistors, 5 plus RS1. So we have 5 plus the same 10.2353. Now when you punch this, you have your I3 to be equal to, now punch everything on the calculator, you are getting 0.64 amps. I hope you got the concept. Now I can find the I4, the current I4 at this branch, because I've been able to resolve 1, 2, 3, which is giving me what? RS1. I don't need to use current divider rule again. So let's subtract this value from I2 to get the I4. So to do that, our fourth solution becomes I4 is giving us what? The total supply current, which is here, I2 minus I3. Okay, so when I do that, I'm getting I4 equals 0.95, which is for the value I2. Where is it? This is I2 minus this one, which is what? 0.64. So now when we subtract this, we are getting what? 0.31 what? Amps. Cross check this and give me a probably if I made an error. So now we've been able to find for I4, we are left with the current I5 and I6. To do that, we need to use the value I4. Okay, I4 is the source supplying to this node. So when it gets here, it split into two. Now we need to locate a diagram that will help us to do that. Which diagram will help us to find the current I5 and I6? It is the same original diagram. Okay, so now we have nothing to resolve here. So we can find I5 by using current divider rule, or you can also find I6. Okay, so let's find I5. So in our feet calculation, we have what? I5 is giving us what? The source current from current divider rule, which is I4. The value of I4, we got 0.31 amps, so we use it to multiply 0.31 times the opposite resistive value, the one that I5 is not passing through. I5 is passing through what? The 8 ohms here. So we have to use this one, the resistive value 9 ohms. So we use it to multiply what? 9. So now we divide the result by 8 plus what? 9. So I have my 8 plus 9. Now our I5, when we punch this, we are having 0.16 what? Amps in 2 decimal places. Cross check again. Alright. So now we have been able to find all the current. I think we are left with I6. So to find I6, we can also use current divider rule, or we just subtract. So our I6 is giving us what? Our I4, which is the supply current, minus our I5, which is what? The one we just calculated. So this is giving us I6 equals what? What is the value of I4? This one. We have 0.31 minus 0.16, which is giving us what? So when you subtract this, we have our I6 is giving us 0.15 amps. Okay, 0.15 amps. So now when you see, we've been able to find the value of I6, I5, I4, I3. We found the value of I2 and what? I1 using current divider rule and by resolving the resistors little by little. I hope you were able to get this. If you have any questions, please drop it in the comment box. So in our next video, we are going to be talking about the superposition theorem. So my name is Daniel. Please subscribe to the Twitter Tech channel on YouTube, on TikTok, and on Facebook. I'll see you in the next one.